Hello all. So in the last few sessions we have seen how do we implement regression algorithm. So we have seen three different types of regression algorithms using a sample data set. So we have seen how do we implement simple linear regression, multiple linear regression and polynomial regression. So far when we try to implement the regression model, we have seen how do we work on with prediction. Okay, so when I say prediction, how do we give new data for the machine learning model which we have developed, and how do we obtain the predicted results of that particular new data or the data existing, right? So, but we did not find out the accuracy or the performance of the model. So today in this session I would like to talk about regression metrics. That is, when I talk about regression metrics, how do we measure the performance of the regression algorithm that we have already developed so far. Okay, so today we will be discussing about metrics for regression. So we have seen regression is a machine learning algorithm which actually helps us finding the relationship between independent and dependent variables, right? So if you want to develop the machine learning regression algorithm, not just finding the values but also performance metrics are important, which will actually evaluate the model's performance. Okay, so before we actually step into types of regression metrics, I would like to focus on two important terminologies. Okay, so we have been talking about true values and predicted values every now and then we were discussing when we were discussing about the topics, right? So these true values and actual values are nothing but if you work on a data set. Okay, so you have x input and y output variables, right? The values which are actually given are called actual values, and the values which the machine predicts are called the predicted values. Okay, so the performance of the model is basically assessed based on these two terminologies. What is the true value and what is the machine which is actually what is the value which machine has actually generated. The difference between these two will actually gives you the error. The less the error, the more the model is performing well. More the error, the model performance or accuracy is gradually less. Okay, so true values and predicted values are actually important for us to assess the model performance, which will actually gives us a clear understanding about how do we evaluate the regression metrics. Okay, now when we talk about regression metrics, they're actually used for evaluating the performance of the model by quantifying how well a model predictions actually matches with the real values. Okay, so there are different types of regression metrics that we actually use for assessing the regression model specifically. So now let's look into them. Okay, so there are four different major types of regression metrics algorithms. One is called as mean absolute error, second one is mean square error, third one is root mean squared error, and fourth one is R square error. Okay, so apart from R square error, we also have extension for this, which is also called as adjusted R square. Most probably we will be using the first four, which are the common regression metrics, that is mean square error, root mean square error, mean absolute error and R square error. Let's discuss about each and every metric in detail. Okay, first let's start with mean absolute error. Mean absolute error is nothing but the average of the absolute differences between predicted values and actual values. Okay, now when you look into this formula, I am taking the difference between actual value and predicted value. Here y is the actual value, y cap is the machine predicted value. The difference between actual value and the predicted value, so we may get negative value, for which we take the absolute value of that. Okay, and we may not have one data point. When I talk about yesterday when we were discussing about house price prediction, we were taking the house prices of 5 different houses, right? So I have 5 different values and I may generate the outputs for 5 different rows of input, right? So for that reason I go for summation, sum of all the data points given in the data set, summation of the absolute difference of the actual value and squared value, and I'll take the average of that. Hence we say MAE is nothing but the average of the absolute difference of the actual output and the predicted output. Okay, now this MAE will actually measures how close the predicted outputs are when you compare them to the actual outputs. Okay, so lower the MAE, higher the performance. Okay, so lower MAE indicates better model performance as it implies smaller error. Okay, now when you talk about this particular regression metrics, it is less sensitive to outliers than other metrics. Okay, so outliers are this model is very less sensitive to outliers because it does not square the error. I am not performing the squaring of the error, however it may undervalue large errors. Okay, so this is all about the first regression metrics, which is called as mean absolute error. Okay. Now the second type of regression matrix is mean squared error. So instead of taking the absolute of the difference between actual and squared, here we take the squared values. Okay. So MSE is nothing but average of the squared differences, average of not the absolute difference but the squared differences of the actual and predicted values. Okay. So squaring this particular term, that is square difference between actual and this thing, will actually penalizes large error more than small errors. Okay. Now when you talk about MSE, lower MSE values are preferred. Okay. So the lower the value, good the accuracy is. Okay. Now when you talk about sensitivity, MSE are highly sensitive to outliers because the errors are squared here. Okay. So when you have more number of outliers in the data set, we usually prefer MAE instead of MSE. Okay. So because of this, it causes the model with high variance to have higher MSE values. Okay. So just understand the difference. When we talk about MAE, we have the absolute difference of actual minus predicted. Here we have squared difference of actual and predicted values. Okay. And the third type of regression matrix is root mean square error, which is nothing but square root of MSE. Okay. So here I have square root of the difference between actual value minus predicted value by the square. Okay. So RMSE is the square root of MSE. It provides the error in the same units as the dependent variable y, making it more interpretable. Lower RMSE indicates better model performance. Hence, we try to reduce the large errors because of this particular performance metrics. Okay. So when we talk about sensitivity, like MSE, this is also sensitive to outliers. Okay. However, we use this RMSE, which is more interpretable than MSE because of the squaring which is performed. This next type of performance metric for regression is R squared. When we talk about coefficient of determination, when we talk about implementing regression models with statistics, okay. So when we have discussed that, we were using R square method. Okay. So here R square actually represents the proportion of variance in the dependent variable explained by the model. So here the formula is given by the square of the actual minus differences 1 minus the square root of this by this. Okay. So here when we talk about R square, we usually use R square when we have more dependent variables, or when the proportion of variance in the dependent variable is explained by the model, we will be preferring R square method. Okay. So higher values closer to 1 indicate that the model explains a large portion of the variance, as R square of 0, when you talk about R square of 0, which means that model does not explain any variance, while 1 indicates perfect prediction. Okay. So the closer the value is near to R, the closer the value it is near to 1, the R square have perfect prediction. That is, the performance measure is more and the error is very less. Okay. When you talk about sensitivity, this is very sensitive to data variability. When you have huge variations in the data set that you take, this is not preferred. This particular performance matrix is not preferred. But when we talk about measure of error magnitude, okay, when you have high dimensional or overfitted models, we will be making use of R square method. Okay. Next one is adjusted R square method. Okay. So adjusted R square method actually modifies the basic R square method by adjusting the number of predictors in the model. Like, as you can see here in the formula, we use one value K. Okay. This is a predictor value that we use, which will actually adjust the number of coefficients that we take, which will affect the performance of the model. Okay. So by using this adjusted R square method, we can, overestimate the model's performance by adding these predictors. Okay. So higher adjusted R square suggests a better model fit when penalizing to unnecessary predictors. It removes the unnecessary predictors and considers only the predictors which are actually required. Okay. So when you talk about sensitivity, adjusted R square is particularly useful when you compare the model with different number of predictors, as it accounts for added complexity. Okay. So this is all about 4 different types of regression metrics. Most probably in our real-time applications, whenever we implement a regression model, we'll be either making use of MAE. When you have more number of outliers, we will be using MAE. If you have a normal data set that you're working on, we'll be making use of either MSE or RMSE. Okay. So this is, if you want more interpretability, we go for RMSE. If you have just normal data set without much outliers, we'll be going for MSE. If you have more number of outliers in your data set, we will be preferring MAE. Okay, so this is all about mean square error, mean absolute error, root mean square error, R square error, and adjusted R squared metric. Okay, so not just knowing or understanding the metrics, but also it is very important to choose the right metric to improve the model performance. As told you, depending on the data that we work, we have to choose. Even if it is a regression, you must be working on different data sets which have continuous values in the output, for which we have to choose a regression algorithm. But the right metric that we choose will actually evaluate the model performance well. Okay, so these are some parameters that you have to consider when you want to evaluate the model with good accuracy, considering the right metric. First is, metrics like RMSE and MAE provides error in actual units, making them interpretable as discussed. Outliers, if the data has outliers, MAE, the basic one, is more preferable because it is less sensitive to outliers when you compare to MSE and RMSE. Okay, next, if you are going for percentage based accuracy, we have other models other than RMSE. We have MAPE, SMAPE. Okay, you can also go for that when you talk about percentage based accuracies. When you compare the model performance, model comparison, adjusted R squared explains the variance score, which is more valuable because we add predictors and all that. Okay, so depending upon the model, selecting the best metric will depend on your specific goals, data properties, and the application context as well. Okay, so this is all about performance metrics. So in the next sessions, when we work on the experiments, we won't just stop in predictions like what we have done. After prediction, the next step in the machine learning algorithm would be evaluation as well. Okay, so first we'll import the libraries, read the data set, and then develop the model, predict the values for the model, predict the values for the new data points given, and then you also have to evaluate the model performance using the given metrics. This is all about today's class. Thank you.